All right, I think I'm going to go ahead and get started. Hello everyone, this is Adam with Energy Toolbase, and on the line with me today is Evan with HelioScope/Folsom Labs. We're going to be the co-presenters on today's webinar. We are both very excited to be hosting this, kind of co-hosting this webinar today. This integration has been something that we've been wanting to do for a couple years now, and our version 1 is finally here. So we're really excited to show this off. And we really kind of long felt, I'm just speaking on behalf of Energy Toolbase, that HelioScope is a very complementary product to ours. And we're going to show you exactly how throughout the course of this demo. So I have two very quick housekeeping items, and then we'll just dive right in. Number one, this is being recorded, and we're going to send you the link right afterwards, about an hour after this. And you can share this with a colleague or check out something you missed. And number two, this is definitely interactive. So we encourage questions, chat it over through the GoToWebinar client, and Evan and I will take those at the end of our prepared material. So cool. Without further ado, let's look at the agenda. Pretty straightforward. Evan's going to kick things off and just kind of do a really quick high-level overview on the HelioScope product and dive right into a demo and building up a commercial project from scratch. He's then going to pass it to me, and I am going to demo importing all of the data that Evan's built on the HelioScope side directly into Energy Toolbase. And then kind of the last section is where we'll both share thoughts on, the benefits of really using two best-in-class tools in conjunction with one another. So without further ado, Evan, why don't I pass it to you?
Okay, great. Thanks, Adam. And yeah, I would definitely echo the sentiment that these two tools tie together really, really well. And we've had a lot of customers that use Energy Toolbase give us great feedback on this integration so far. It basically allows them to go from start to finish. So HelioScope, basic way to think about it is as a combination of the best features of AutoCAD and PVSys. So your layout tool and your production model rolled into one. And the huge benefit of having them together is that you can get feedback really quickly. But I would say the biggest advantage is that we give you bankable engineering caliber results in a very fast time frame. So if you wanted to learn CAD from scratch, it might take a few months to learn to really actually be able to contribute to the engineering team. With HelioScope, we have customers that say they can get people up to speed in a day or two from off the streets, no solar experience, contributing to their engineering team. So it's just a dramatic shift in how people think about getting very, very good answers. We've been validated to be within 1% of PVSys, for example. And that was done by an independent engineering review by DNVGL for a bank. That sort of level of answers at the click of a button. And so that really just changes the game when anybody in the company can get these results. So whereas before you might have had a bottleneck with your engineering team that they're working on every single project that's coming in, and their turnaround time, if you're lucky, is hours, and if you're not, it's weeks. Somewhere in between is probably normal. Well, now the salesperson can get this answer to the customer from initial email back to the customer within 30 minutes, right? How much is going to fit on this roof, and how much energy is that going to produce? Those are the two sort of fundamental, sound simple questions, but have a lot of physics and engineering that go into those answers. And before that was sort of restricted to the engineering team's department, and now anybody in the company can get those answers very, very quickly and very, very accurately. So that's sort of the high-level way to think about HelioScope, and we give you sort of hourly production results of what this array is going to produce, and that's fantastic because Energy Toolbase needs hourly production results. Well, not exactly requires it, but it really, really helps to make a much more detailed analysis of the financial and to build that proposal out. So actually what I was going to do is, Adam, if you want to pass me, I'll start demoing how to do a design in HelioScope. So Thank you, Adam. This is the HelioScope homepage, and you can see I've got a list of some demo projects here that I've been working on, and I'll just create a new project. We're going to do a commercial system, but you can do flat roof systems, you can do residential designs, you can do megawatt ground mounts, all through the range. I'll just show you, and what's nice is the principles that you learn for commercial apply to residential, apply to ground mounts. It's all sort of the same tool here, all cloud-based. So I'm just going to click here on New Project, give it a name, and since this is a demo, we'll call that Commercial Demo, and the address. So I'm going to call this, I'm just going to go to Kansas City in general. You can put in a street address, you can put in lat longs, you can even put in Disneyland. Basically anything you can find on Google Earth, you can find in HelioScope. So you can zoom out and scroll over to a project location. And this is the first time I've done this project in this location. So exciting times for you guys. Normally, I've done this building many times, but I wanted to do this one for fun. So we're going to grab this site right here. And under Profile, we have some defaults that just really save you time in sort of what your layout assumptions are going to be. So I'm going to choose Default Commercial, and you'll see those come across when I create my design. So I just go in Default Commercial, Create New Project, and that's going to take me to the project page. And you can see I've got a few different tabs here. Designs are everything that I control about the site, so where my modules are going, what type and what type of inverters, all that sort of stuff. Everything I don't control is about condition, is going to be in the condition set, so the weather and the sun. HelioScope makes some default assumptions for me. I'm not going to really go into that in this training, but you can edit those assumptions. And when you combine those two pieces of information together, you get a report about the energy yield. And that is the sort of validated production report, and I'll go into that once we finish one. So let's get started by going to Designs and clicking New. And we'll just call this our baseline design. You could leave it as Design 1 if you wanted. And here we go. We're inside basically a Google Maps image of this area. I also have different mapping tools that I can use. So Google is the default, but I could also switch to Bing. So Bing, in this case, gives me better imagery. So I'm going to use Bing. And I'm just going to do this building here. And so what I'm going to do to start is I'm going to click New on Mechanical and define my area. So I'm just going to click into the corners of this array. And if I hold Shift, I get 90 degrees locked onto there. So I'm just going to hold that, and then finish the shape for me automatically. Just double click to end the shape. So you can already see the setback here. We've got a 4-foot setback defined in my profile, so I don't even have to set that. But we can also select a module from my favorites list. If you set this up in your profile, you don't have to select a module, but to get started, you can search for one. So I could say I want a Trina 300-watt module, and we get the list. We have over 40,000 components in our database, so really easy to get the module you want. And you can see it lays out to the south with my default assumptions. So a tilt of 10 degrees, a row space of 2 feet, and a setback of 4 feet. That's all in my profile. I can customize those, and I can edit them inside the design. So for example, I might want to change the azimuth of the array, so I can change the orientation. I can manually enter in a different value, and you can see that rotate. I can also use the up and down arrows to sort of get this the way I want it. The easiest thing to do, though, is just to right on the mid of a line and set the azimuth, and the modules line up to that edge. I can do that in sort of any direction, so I can face them west if I wanted to, but I'm going to prefer south in this case. Now, we can also adjust the tilt. So if I went with a really extreme tilt, like 60 degrees, you can see the modules are really thin from the top down. So we are accounting for the geometry correctly. We also account for inter-row shading. So if you're worried about the spacing here, if you don't have a default value from the racking manufacturer, you can use our row spacing optimization tools over here. So you can define a span to rise ratio or a ground coverage ratio, or my favorite is time of day, where it basically spaces the modules so that they don't shade each other between basically whatever hours you set. And the default is 10 a.m. to 2 p.m. on the winter solstice, so just a 4-hour window there. And what's cool about that is if I was in a different latitude, if I was a different part of the world, I would get a different answer. Or if I was at a steeper tilt, so 15 degrees, that's higher up, cast longer shadow, I do that same time of day analysis and more road spacing. So we are accounting for all of that there. Okay, now I'm going to move on to Keepouts, which is basically defining where I don't want modules to go. So if we look at this, got some obstructions, it's kind of messy. So what I'm going to do is I'm just going to draw these a shape for this keep out here. So let's just draw this skylight. And what's cool is you can define this once and basically be done. So let me do that. Give it. You can get a setback off of here of half a foot or something. You want to give it a height to model. If it has a height, you can model the shade impact of that object. And once you have it, you can just copy it around to other obstructions. Oops. Sorry, I clicked on the segment on accident. All right, so we just grab that, copy it around the roof, and this will account for this obstruction. And so we have all these similar objects, really pretty quick to get these accounted for here. And you can also do whole areas. So you could say, you know what, I don't want to specify each one of these down here. I could just draw this whole area in, but I'm going to do it just because I'm sort of committed. And here we go. And one more here. Okay, I think that looks good. And we can quickly switch to add a new custom one here for this small shape. And then edit and copy that as well. All right, so you can do that for all the different types of objects you have on your roof. Really quickly get those set up. I think I missed one here. You can also define a height. So if you have an HVAC unit like this one, you can just draw this here and give it a height. So let's say that that's 5 feet. We get the shade pattern for that object on the winter solstice from 10 a.m. to 2 p.m. and it removes modules that would be shaded. All right, I'm going to add one more keep out here for this guy. And I think we'll move on from keep outs to find that height. That's 3 feet. Okay. Oh, one last type of keep out we could add is if we need a maintenance path across the roof, we can just draw this out here, double click. This one is just a path, so we can give that a height of 0. And then we can add one more going north and south. Cool. All right, so that looks pretty good. I'll do one more thing. We can also define the height of this building. So we could say that this is a 20-foot tall building, and if we view this from the side, we can see how that building would look. And what's cool about that is if we wanted to do a carport nearby, we could model that as well. What I actually want to model is this building here. So I'm going to draw a keep out for this building. And since I have the height of my building already defined, I want to put the, whoops, get out of here, Mac, double click there, and we'll just give that a height of, let's say, 60 feet. And right now it's removing all those modules that would be in the shade pattern. But I'm going to be a little bit more aggressive. I'm going to leave the modules in the shade, so I'm going to uncheck this. And the reason I do that is we can do this advanced shading analysis. Actually, let's check it from the side so it looks cool. All right, so advanced shading, we can calculate how much energy each module would be losing due to this obstruction. So you can see these ones that are right by it obviously lose the most energy. And so what I can do is I can use this slider here to set a shade tolerance. And actually what I'm going to do, well, before I do that, I'm going to squeeze this system for a little bit more kW. I'm going to go to a smaller tilt, like a lower tilt, pack in my roof a little bit more. Okay, so go there, do our shading analysis, because I'm trying to target about a 150 for this customer. So I'm packing in the roof. I'm going to bring this down to about 150. Okay, so I'm basically just removing my worst modules to get my kW rating, and you can see this is removing modules based on how much energy they lose throughout the entire year. So whereas before we were doing winter solstice 10 to 2, the winter solstice is the least interesting time of the year from an energy production point of view. I want to look at the whole year and see how much energy each module loses. This is a much better way to remove modules. So I'm going to remove those 97 modules. I got about any module that's left has a 88% solar access rating. I think that math is right. Just 100 minus 11.7. That's what it's showing you there. So I'm going to remove those extra modules. And I have the option to sort of go in here and clean up any spare modules. So I can right-click on these modules here, for example, this module here. And I can also bring modules back. So if I want to have this full row, I can do that. Okay, so there's our layout. That looks pretty good. Now what I'm going to do is I'm going to go to electrical, and I'm going to define my inverter. So I can select from my favorites, or I can search. So maybe this is a really shaded array. Maybe I want to do Solar Edge, or maybe I want to do an SMA 24,000. Up to you. Grab that inverter, and HelioScope will give you a count of inverters that targets a DC ratio of 1.25. In this case, we're at 1.24. So as close to that as we can get without going over. That happens to be 5 inverters. I can manually set my inverter count, or I can set DC to AC ratio targets. So if I say I'm okay with up to a 1.6, maybe you've got a letter from the inverter manufacturer saying you can do that. Well, HelioScope can adjust based on that. But I'm actually okay with a 1.3, which gets me 1.3 gives me the same amount of inverters. And in this case, I can just drag my inverter so they're all in a line here. Up to you. We also give you the voltage drop by wire gauge. So for each gauge wire, we show you how much voltage drop there is. In this case, not very much because the inverters are all sort of centrally located. But you can see what that would be if I went up to 14 gauge copper. It would be about 1%. I think I'm going to stick with 10 gauge here. And this is actually easier to see in single line diagram mode. If we go over here, we can see the single line diagram actually gives you a really nice way to evaluate your stringing options. So in this single line diagram, we can see we're going from strings into combiner boxes, into recombiners, which don't seem that necessary, so I'm going to remove those, and then from the recombiners into the inverters. This recombiner here is a one-circuit recombiner, so I can actually just remove that. Click X remove. I can remove the combiner boxes as well. Just sort of simplify the design. I can add those combiner boxes back in. The stringing is done automatically based on the temperature range in this location. If I'm fine with this stringing, I can just move on. I'm done. I can just save and exit. If I want to modify the stringing, I can set it manually. So I can say, hey, I only want strings of 18. Well, that would cut my inverter, my module count to obviously an even number, right? Because it has to be divisible by 18. Whereas before, when we were at 5, we had 499 modules, so you get that count right there. So you would lose modules by being less flexible. HelioScope's stringing algorithm optimizes to have first to collect all the modules, second to balance between inverters, and third to prioritize long strings wherever possible. So in this case, I have a minimum threshold of 5 modules, but I never go below 16 modules because I can hit all of them. Okay, so that single line diagram can be exported to DXF if you want to customize it. We can save and exit here, and we can go to the Reports tab and simulate the energy yield of that array. We can also download the layout of this drawing to CAD. So if you have if you want to finalize something or you want to submit this for permits, you want to send this to your engineer, thankfully you have a pretty nice DXF that you can send them. If you want to, instead of having to try to communicate what you sold, you can just send them exactly what you did. And so here it is. It comes with the satellite image as a base layer. I can turn that off. And then we can view this in 3D. And you can see this is a fully 3D CAD file. So I can zoom in. You can see the spacing between our modules is accounted for there. So a full CAD file that's fully editable. get back to HelioScope. So our report has finished, so we can see our productivity on a per watt basis. If I zoom in here, this gives us the full report. So I can, let's view this. So we get monthly production, which is just sort of summarizing that. We also show you your losses by month here and the losses of the system. So we can see we have 3.2% shading losses, 3.9% mismatch loss. So if we were to try to optimize this with an optimizer or a microinverter, we can see what's the maximum we could get back, excluding efficiency losses. This is the loss table. So if you were to step through this, this matches PVSys 1-to-1, within 1% for each one of these line items for every hour of the year. So we're using the exact same mathematics as PVSys, but we just do it at the module level, so that you can do that kind of comparison between string inverters and optimizers and sort of the real detail for shade analysis. At the bottom of the report, we give you the component list, so your inverter count, wire content, combiner boxes, and module count. And then the pretty picture at the bottom that you can show the customer. Right now, this is showing inverter locations and wiring and everything. I can simplify this to just show modules, so I'm just going to uncheck all those and click export, and that will re-render the design to just show where the modules are located. Let's see. All right, so here's the updated image with just the modules. So you can customize that to whatever works for you. All righty. Now, that's the sort of the first part of what I was going to demo. So Adam, if you want to take over from there. I gave you a 149.7 kW inverter, or excuse me, system. So if you want to take that into Energy Toolbase and see what we can do with it, that would be great.
Perfect. Let me try to take the screen back. It looks like I'm back on. Awesome. Fantastic setup, Evan. And now let me take it on my side. Let me start with just one very quick slide, kind of overviewing Energy Toolbase. I feel like most of the folks on the line today kind of already know us. What we're really focused on and what we're really good at is utility rate and avoided cost analysis. So quantifying in dollar terms how much a solar or storage or efficiency project saves. So without any further ado, I just kind of want to go right into showing off all of the work that Evan just did, how easy it is now to port that directly into Energy Toolbase and run all of that avoided cost analysis on it. So as Evan was doing his pitch, I was actually just building a brand new lead. So all I've set up thus far is a lead. We're actually going to step directly into a proposal. So this is almost as if we're doing this for the first time. We'll call this a HelioScope demo. And we'll really quickly move through the 7-step process, which I think a lot of you are already familiar with. Let me just call this a commercial deal. We'll move right to step 2, utility rates. I am going to create an energy use profile. Again, the folks that know us know this is definitely one of our specialties, which is rebuilding that 365-day utility bill. Why don't I also kind of show off our recently launched utility API integration, which we're very excited about. And this functions pretty similarly to our HelioScope integration, because what happened right here is we just pinged a user's utility API account, and these are all the deals that are sitting in that account. So this one here happens to have 12 months of interval data, so I'll port that in. And effectively what utility API is passing us right now is 1 year of 15-minute interval data, which is about 35,000 data points. I am going to, how about I name this utility API just to be clear. I am going to assign this against a particular utility and rate schedule. I'm in California here where I created this lead. I know that doesn't jive with the project you had in Kansas, Evan, but I think for the demo, this will suffice. Also, really quickly mention, this is actually something that's a really widely used use case right now in our application. Users can custom create their own rate schedules, and a lot of folks are modeling, certainly in California, the proposed time of use rate changes that both the utilities, the IOUs, have submitted, and also what are being called kind of the middle ground or compromise proposals that CalCIA has submitted. And this is actually going to be something I'm going to demo in just a second because it's really very valuable. Once you have a customer's raw load profile and you have a really bankable, verified solar production profile, really quantifying the effect of rate changes, and in this case, on-peak time periods shifting much later into the evening, we can really precisely and transparently quantify what that delta is. So let's set this on a commercial rate. Let's call it the ALTOU. And again, all of this data came in from Utility API, so we factored all of that data into the table based on the schedule and the sub-attributes of the schedule that I defined. And we always default to the most recent effective date. So this is all as of March 1, 2017. And we actually just recently launched this feature. I'm not supposed to be talking about this. I'm supposed to be talking about the HelioScope integration, but I can't resist. This is a really cool view of seasonal demand profiles, average demand profiles. And you can see this file that I brought in from Utility API here is actually a pretty, I call this high load factor, or really pretty consistent looking load profile. You know, not a lot of variance. I actually happen to remember this particular meter was a small supermarket that had a lot of cold storage. And you can actually just see it in the shape of this profile. There's just not a lot of high to low variance, and there's a lot of always on load. So that's what we're going to do initially for this. So I'm going to save this. We're back in the proposal editor. I am going to set up a rate switch here. Let's propose moving this customer to the solar-friendly DGR schedule. And we're going to choose the schedule with greatest savings. Maybe I'll talk about the demand throttle reduction in a minute, but for now we'll just look at doing a rate switch, and we're going to choose the schedule with greatest savings. Let's move on to step 3, and this is really not real critical to what we're talking about now, so let me just set up a couple incentives. And now here's where I really get to talk about the integration. So as I add a new solar system type, this is my new menu of options to choose from, and we're very excited to have this logo here going forward. So I'm going to click on the HelioScope integration logo, and what happened is this account is linked with a HelioScope login, and it actually just takes about 5 seconds to set that up. If you had not set up your integration yet, when you clicked on the HelioScope icon, you get prompted to enter in your HelioScope credentials. So we are now handshaking with that account. And what was the name of that deal you had just created, Evan? Was it Baseline?
Yeah, under commercial demo.
Gotcha.
Was
Voila.
the project.
Perfect.
And then there's only one design.
There she is right there. So, and I can even do a really quick preview of all the work Evan had just done. So it's really cool. Any iterative changes he's making on his end, you know, in the course of me talking, he could have ran a couple of different simulations or versions of that existing deal, and all of those real time will, you know, be searchable and importable right on our side. So I'm going to bring in this deal. Notice on the equipment side, we do have you create equipment, and this is a one-time exercise, and usually I just kind of click through and use all the defaults that HelioScope's defined. But if you want to kind of set up and mirror your equipment that you're choosing on the HelioScope side, again, you just do this once, and that's now kind of saved within this account. Okay, so cool. This is all of the data that HelioScope just passed us, basically the equipment, the 8760 solar production data, and also the imagery data. And looks like there was, actually in this case, only one condition set. So let us actually go through to a finished proposal. Then I'm going to circle back and talk about the optimizer. And this is really, I think, a very, very powerful workflow. I know a lot of folks on the phone or on the webinar today are kind of more advanced users. They already know how the HelioScope product works. They already know how Energy Toolbase works. We're going to be kind of giving you some value today too, because there's a really cool kind of, I think, workflow tip that I think you're going to want to leverage when you're using both of our tools together, and it has to do with the optimizer. So let's save this and just go through to a finished document. I'll just add a transaction very quickly. How about we do a cash purchase? Maybe I'll throw in one more just for fun. How about a loan? I'll call this a PACE loan. And I'm just going to make something up. How about 7.5% interest over 20 years with federal tax deduction? And without any further ado, let's go to step 7, documents. And this is really where the integration kind of gets to show itself off. So as a lot of you are already aware, you can create as many document templates as you want, or you can choose from our gallery. I actually just threw together a new one for today's demo called the HelioScope template, and we're actually going to be uploading this to the gallery, so you'll have access to this shortly. And we've got a placeholder image. So I'm going to select the image we brought in from HelioScope, and here's all the work Evan had just done. Why don't I do some kind of sizing of this to really make it kind of pop? So we'll bring that image in, and this is basically going to get embedded inside a pre-configured document template. I just threw in a really quick Folsom image or logo. As everyone knows, this is completely customizable and really, I think, easy and intuitive to, style this, your color schemes, your logos, your static text, your referenced variables. This is all data before. This is solar production data, and all of the, in this case, orange data is what we just ported in from our friends at HelioScope. So this is on a monthly basis, exactly what all those production values are by billing cycle. And we're going to look at the breakout on an interval basis in a minute. And then here's kind of a new page where we're really just highlighting the work Evan had done on his side, the equipment he built, obviously the design, KWDC rating, first year production, and the yield. So you get the sense here of just kind of how integrated this is. And again, obviously, when we get down to the avoided cost page and we're quantifying in very precise terms how much this deal is saving, as I mentioned earlier, this is Energy Toolbase's specialty. This is all based on that validated, bankable production data that we ported in from HelioScope. So pretty straightforward. I've even got another template maybe we can really quickly look at, and I just kind of want you to envision how flexible it is. I think I call this one the Marketing Slick template. Let's bring in another one, do a little bit of styling again. You can, of course, choose to go wide or tight. And basically the only difference here is how that image fits in to the style sheet. So in this case, hey, now we're kind of doing it in the context of the PV system detail on this one single page. So really flexible in that sense. When you're creating document templates, you can create your placeholder however you want it. It could certainly be on a cover page in a box. It could be an entire page. You could do text and reference variables around it. And we think really flexible for you to kind of show off, the robustness of the production modeling that you've done utilizing the HelioScope tool. So that's a very quick overview. Now I want to kind of show that advanced trick. So let's toggle back to the project, and I'm going to go to step 4, which is where we've ported in all that HelioScope data, and I now want to run an optimization against it. And you know what, before I do that, let's get a little crazy here, and I'm going to set up some NEM 2.0 assumptions. Bear with me, rather than me talk through all of this, let me just kind of set this up and go with it, and then we'll kind of interpret the results together. Okay, so back in step 4, we're now going to run an optimization against the production data that we captured from the HelioScope side. And effectively what we do here is we simulate 10 different system sizes. And based on the unique consumption data that we ported in from Utility API, of course based on all of the unique 8760 production data HelioScope gave us, and also based on the utility rate schedules and the layered set of assumptions, I had just kind of configured some NEM 2.0 assumptions for the DGR schedule, where non-bypassable charges are valued at 2.5 cents. In other words, all of the exported energy is getting about a 2.5 cent haircut that's going back to the grid. So let's look at this chart here together. This is kind of the bottom line here. This is the total electric bill savings. And again, as I hover my mouse on the chart, we're looking down here at about 195 kW DC rated system in the x-axis. And this is kind of cool. You can actually even zoom in. And generally what I'm looking for here, the inflection points are happening right around the hip of the curve. So let me zoom in on that. I'm going to kind of re-simulate this. And we just drew a much tighter range there, right? Now we're simulating between a 146 kW DC rated system and a 219. And as you can see here, the green line's always higher, quite a bit higher, meaning this customer would get much greater savings opting onto the DGR schedule. So let's just kind of, for simplicity purposes, remove the ALTOU. And what I'm really now kind of zooming in on is where this plateau effect is happening. Because think about what that means. You know, as we build a bigger system, starting at 146 kW, based on this customer's unique load profile and the production data we captured from HelioScope and Evan, well, right around 187 kW, as we build this particular customer a bigger system on the DGR rate, assuming 2.5 cent non-bypassable charges, we're getting a very diminished marginal return. In other words, you can build them a bigger system, you ain't going to save them any more money. So you can build as big a system as you want, but it's not in the best interest of the customer for this particular project. So I'm really kind of honing in on somewhere in the neighborhood of about 180 kW DC rated system. So Evan, maybe I'll pass it back to you, or maybe I don't even need to give you the screen. If you just kind of want to really quickly on your end, I'm putting you on the spot here, maybe version out that proposal at 180 kW, and then I will just port that design as a separate versioned out design, and we can kind of run a really optimized system. And I should have given you a little bit of a heads up. I told you actually we were going to be sizing down. I changed my mind here. I brought it in a different load profile. We're actually going to be sizing up.
Okay. Yeah, that's no problem. Let me run. I'll give you two options, and you can choose.
Sweet.
What was the KW again? 180.
180. Let's call it 180, 186. Yeah, in that neighborhood. I think it's going to be just about perfect. And while you're doing that, I actually want to mention one other thing, and that's exported energy, because we did set this up such that I configured some NEM 2.0 assumptions. And this table down here on bottom is really powerful. So again, this is based on all the HelioScope data we brought in. Actually, you know what? I should probably resimulate this from 0 to full. Yeah, I got to go 1 on the min, 1 to 243. So let's talk about exported data while Evan kind of does his thing. And basically, on the chart on the bottom right, we're showing two things. We're showing solar generation for different system sizes. And again, this is based on that HelioScope design. And this is the one I really want.
Just so you know, I've finished mine. I just wanted people to know how fast I was.
Dude, you're ruining my
I mean, you can talk about your thing. I just don't want people to keep me that long.
Let's we don't even need to talk about this, but this is effectively showing how much energy is getting exported. Again, very, very specific to this customer's load profile and the design that Evan built. And actually, I'm going to break down and show kind of the interval basis of this in a minute. But without any further ado, let's do this. Rather than overwrite this, why don't I go back to my lead level, and I'm going to copy, duplicate this proposal. I'm going to call this HelioScope demo optimized. So we're going to version out a separate one. I'm going to go right to 4. I'm going to delete this. I'm going to bring in a new HelioScope design. And there's that commercial demo, and you can see here, this is kind of cool. Evan has got 4 designs, 3 reports under there now. So which one is it? The larger?
Yeah, the larger one. I also did an east-west version if you wanted to check that out. But yeah, the larger design.
Let's check that
out. The larger design, I think, is going to be more comparable to the last design.
Gotcha. Well, either way, I think everybody on the line gets the idea here. The minute you save a change on the HelioScope side, it's instantly recognized here on our handshake with them. So really kind of powerful. I know a lot of folks who are using our tools kind of have maybe the 2 monitors set up. They've got the HelioScope on one side and us on the other, and it's that instantaneous. So let's just bring in this larger design. And look how this looks. Looks like you still have 1 condition set. Obviously pricing I didn't mention, but of course users can determine pricing. So let's go and build another proposal. Let's use that HelioScope template again. This is the larger design. We can tell there's more panels than we did on the initial, so we'll bring that in. Do some sizing. Actually, why don't I even do big so I get the HelioScope logo this time. Obviously, users' discretion on how they want to frame that. And we're stepping directly into that new finished, optimized system. And let's actually see what Evan did. He doesn't have to tell us. On the solar size, it looks like he did it. We're exactly at 180 kW DC, 156 kW AC, producing 215,354 first year. Looks like he's up to 600 Trina panels, 5 Solar Edge SE33s, and here is that updated design. And again, what we did there is we really optimized for average blended savings. Value of solar expressed in dollar per kilowatt hour terms. So a really powerful illustration of kind of leveraging these two tools together and kind of letting us both do what we're good at, and you know, really right-sizing and optimizing this project for this particular customer based on his load profile. So maybe now we'll transition into kind of just talking about the benefits. And why don't I start on this, Evan? And a good segue for this is for us to step into the analytics module. And let's go right to the data visualization tab and kind of really talk about the back end of what's happening here. I always kind of like going to a summer month. I just think a lot of times it's more representative. Okay, let's talk about a week in August. So let's remove some data to start. And again, this is kind of now the you know, the part of the presentation where we're going to talk about the benefits of leveraging these two tools in conjunction with one another. So right now, all I've got selected is current usage data. And again, this is a pretty funky looking load profile. You can kind of see that this way this guy operates the building, they actually have this hole right here, right around, looks like 8:45 to 1:30 p.m. where they're cycling off, and it's a pretty consistent hole. Actually, this is very clever of them. Check this out. I don't know if they're doing this intentionally, but they're actually cycling off on the on-peak period. So I don't know if this is coincidental or not. I didn't even plan this, but you can see here I have the energy ALTOU cost specified. So this is the on-peak period, which runs from about 11A to 6P currently. And you can see this customer happens to cycle off in that period. So they're kind of actually, you know, saving by you know, shifting some load there. Now let's overlay the HelioScope data. So this is you know, the 8760 that Evan passed us, and I can go full range. Of course, really important to note, there certainly is obviously the variance in that data. Maybe Evan can speak on that in a minute, just kind of utilizing the TMY methodology. And then we can also simulate net. And this is really now where we're simulating and calculating that exported energy. And this kind of leads me into, you know, there's a lot of benefits of having bankable, validated production data. I think a lot of times users of Energy Toolbase previously had used PV watts just because it's quick. Not necessarily because it's accurate or very rigorous, but you can just build a PV watt simulation in, you know, 15 seconds and it's good enough. It's within 10%, let's say. But now when we start thinking about things like really quantifying the effect of time of use rate changes, or net metering version 2.0 scenarios and counting exports, or simulating the reduction of demand charges, obviously on commercial schedules, very, very important. Actually, I could even kind of show it to you here. If we went to the monthly electricity cost tab, and we're looking at, this is a perfect example. Again, I actually did this on accident, but here it is, ALTOU before the project. I kind of really want to highlight. Now, this is a pretty typical commercial customer. This guy's annualized bill is about 54 grand, of which 23,000 are demand charges. So we're talking about somewhere on the order of 40% of this customer's total bill is demand charges. It has nothing to do with how much they use, right? So when we're simulating the reduction of demand charges, which the user has, you know, full control of in Energy Toolbase, to do that accurately really now comes down to having really bankable and validated solar production data. And you know, that's what we're now doing, kind of sucking that HelioScope data in. And obviously there's variance, and obviously there is, you know, this is still an estimation of what sort of demand reductions are going to occur, but at least it's based on, you know, more rigorous production side data, which I think is the key piece I want to drive home. So that's kind of what I have. Any other kind of closing thoughts on your side, Emin?
No, but yeah, actually, just one thing. You did mention the TMY weather files. So HelioScope has the ability to analyze multiple weather files and condition sets. I didn't go through that in our training. We do cover that in our sort of longer trainings, in our advanced training, where you can compare. And I mean, the fundamental issue with all production modeling software is that we're trying to predict the future of what a system is going to produce based on past data. HelioScope, though, gives you the option to compare different interpretations of what past data, what a typical year will look like. So we allow you to look at TMY2, TMY3, Prospector, and any other weather file that's available in your location. You can even upload your own custom weather files if you want, and that allows us to do much more investigative analysis of what a site is going to produce, and that especially if you're giving performance guarantees, having that level of control and analysis can make your founder or whoever is holding the pocketbook a lot more comfortable with the analysis. So yeah, I think the two tools really give you with button clicks the kind of bankability that your customers would hope that you're doing, and so it makes it very much a button click versus hours and hours of time of trying to run these numbers yourself.
Awesome. I think that's a great segue to Q&A. My only other closing thought was I just want to mention the fact that this is version 1 of our integration together. We certainly have plans to take this deeper, and we really encourage suggestions and feedback from users. We want to hear the things you don't like about this. We want to hear the things you do like. What additional features or tie-ins between these two products would make your life even easier. So please, I know we have some power users on the line here today. I'm just looking at the attendee list. Really want to hear user feedback on this. We've been getting good feedback so far. We are working out a couple kinks and bugs, but really pleased with how stable it's been, and getting some good feedback over the last 2 weeks since we've taken this live. So with that, I think I'm going to start reading some questions. A lot have come in. Let's see here. Evan, first couple for you. Are there a way, actually that person just left, so maybe I won't take their question. Can you elaborate on the condition sets in regards to both HelioScope and Energy Toolbase? Can we just talk through condition sets and iterating on your side, Evan? Oops, are you on mute, Evan?
Yeah, I was saying some really interesting things while I was muted. Yeah, if you want to pass me the presenter thing,
I can certainly do. Actually, there's a couple for you, so why don't you take it right now, and I'll maybe feed you all of yours right now.
Okay, great. So the default condition set is based on sort of industry standard values. These are the values that we got from basically through that DNV-GL independent review. So our values will match PV-SYST within 1%. And the default condition set is going to, the only thing that's going to vary is that it chooses the closest weather file for your condition set. So you can create new ones. So I can just go in and create a new one. I can grab, so the closest one here is a TMY3. I have a TMY2 weather file that's 15 miles away, but there's a whole lot more to a condition set than just the weather assumptions. You can also model different soiling losses. So if you clean your panels certain times of the year, you can model out what times of the year the soiling losses are affected. Same thing with snow loads, those sorts of things. Cell temperature models can be edited, so you can really drive in a variety of assumptions about a site. One thing that I've seen users do is up the soiling losses to model future years and see what it would look like in 10 or 20 years. Mismatch losses, these are default assumptions. You might have a positive binning range. All these sorts of things can be edited. You can even choose what transposition model you want to use. So these can be set up within HelioScope. And then, Adam, I saw you had a drop-down where you could select that in Energy Toolbase if you want to use a specific version of the condition set inside of Energy Toolbase.
Yeah, that's exactly right. It's really cool. You can do is unlimited number of condition sets, obviously, on your end. And again, the minute that's saved on your server and we handshake with you, you're able to choose which condition set you've configured. So really flexible for doing kind of iterative analysis on both sides. Let's see, more on your site here. Now that the production data. Is there a way to determine the height of obstructions?
Yes, absolutely. Is there a way? So Yes. The answer is yes. Help.HelioScope. We've got this article called Shade-Based Height Estimating. Basically what you would do is refer to the date that the image was taken and estimate out the height of the objects from the shadow that it casts. And so we actually step you through how to do that. I can send that link into the chat tool. Let me see if I figure that out. Chat to, I can send it to Organizer. So Adam, if you want to forward that out, that
Awesome.
link basically talks about how to estimate the height of objects from remote. And that technique actually has been validated by NYSERDA and Oregon and other rebate authorities to be as accurate as a solmetric sun eye. So they actually accept HelioScope shade reports in those jurisdictions with using this technique as opposed to going out to site. So saving quite a bit of time and money. And yeah, so that is a technique that we have. There are other ways of doing it. You can use Street View. You can use LiDAR data. We're actually rolling out LiDAR data pretty soon here. That would make that even easier. So there's a lot of different ways of estimating the height of objects.
Awesome. A couple questions for me. Megan is asking about multi-facility analysis. So something I did not mention, but Energy Toolbase really specializes in multi-facility analysis, and that's basically any scenario where you have one or many systems offsetting usage on one or many meters. So that could be net meter aggregation, that could be virtual net metering, that could be like you're working with the Fortune 500 guy that's got 5 buildings in 5 different locations, but you want to show that all in the context of one proposal. So the answer is yeah, we're absolutely set up, and effectively it works the same way we do multi-facility analysis currently, which is users are going to define a system rating for each unique building or meter. And I might have to take it offline a little bit, whether you're talking about net meter aggregation or virtual net metering, because there are some considerations on how you configure and allocate production capacity. But same way you'd expect. I mean, you're basically defining a system for each unique building or meter, and again, kind of similar workflow where you're porting in a unique HelioScope design for each of them, or you could even replicate a design. So I mean, I could bring in that baseline design for 2 of these facilities. So it might be better to take a little bit of that offline because it does start to get a little bit nuanced based on exactly what you're trying to do. But yeah, we certainly are configured. The HelioScope integration is configured to be able to run that. I've got 2 separate questions here asking Energy Toolbase about, they're gushing about how they love HelioScope outside the US, and they're asking if they can use us as well. And the answer is kinda. So today, by the way, if you have a trial seat of Energy Toolbase, you have full access to our entire utility rate database. So we have an in-house team of 4 now that basically all day, every day tracks and updates and indexes utility rates all over the country. And we've got a really cool user interface to view these. You can also custom create your own rate schedules. Now the answer to your question is we do not currently support outside the US rate schedules. And the reason why, it's just a matter of bandwidth for us. We've got our hands full, now tracking rates in over 300 utility territories across the country. It's a lot of work. So we do intend to track rates outside the US in the future. For the time being, if you're using us, effectively what you would have to do is custom create your own rate schedule, which, believe it or not, is a pretty easy exercise. So for instance, if I was to choose any one of these schedules, I could just copy, duplicate this, which is then creating a customized rate in my account. And then I can just toggle to the different types of charges, define the billing methodology, define the charge types, maybe if it has seasons and time of use periods and all the various aspects of that rate. So very customizable, and I think on our last check we can handle about 99% of the rates out there. There are some very, very fringe cases where they do really, really funky things with the methodology that actually requires us to write additional code on our end, but again, about 99 times out of 100, you can just build it right through our front end. But for outside the U.S. applications, you've got to set that up yourself for the time being. It's really not too bad. We've actually got a lot of tutorials on the site on how to do that, but that's the answer for now. Let's take maybe one more, and then we will call this a wrap, and we'll try to answer the rest of these on email offline. Does HelioScope have plans to automate certain aspects of the first cut design process? For instance, automatically recognizing building edges, obstructions, etc.
Yeah, and I would put that in a yes, we do, but it's not a. I wouldn't put that in the immediate future. It is pretty complicated to do that, and the success rate. Basically, what you're asking for is computer vision, and the success rate of that software is definitely less accurate than the human eye, and then really depends on the quality of the imagery that you can get. So it may restrict it to certain areas and certain types of imagery, like aerial imagery. So it's definitely on our list. I think you'll see LiDAR and some other things happen before that. And we definitely see a lot of lower hanging fruit for optimizing and automating some of the layout processes for you that aren't necessarily just using computer vision to tell what the site looks like. Adam, are you muted?
My turn to be muted and talk while nobody's listening.
I assume you were saying great things.
I was saying let's leave it there. For those of you that we didn't get back to on these questions, we'll hit you on email. And then kind of the last plug is, you could certainly get a free trial of both of our products right through our respective websites. So if you're not already using one or both of us, please go through each of our respective sites and sign up for a free trial and test drive and really see if this is a fit for yourself. So Evan, fantastic job. I'm pretty pleased the way as smooth as this went, and also we're going to send out the recording to everybody, within an hour. So thank you.
Excellent. Thanks, Adam. That was great.
Cheers.
Have a good one.
Yeah.